Which of the following pairs has identical values of E by M? That is, what is E by M? It is the specific charge or the charge to mass ratio. Now, do you have any idea about the E by M ratio? Say if I talk of the E by M ratio of electron. So students, what is the charge on the electron? So let's start with the species. I'll first tell you the E by M of an electron. So students, what is the charge on an electron? It is 1.6, that is minus, into 10 to the power minus 19 coulombs, and that is divided by the mass. What is the mass of an electron? It is 9.1 into 10 to the power minus 31 kg. Right? So this is the way how we calculate the E by M ratios, and it comes out to be, and this is equal to 1.76 into 10 to the power, how much it would be? 31 minus 19, 11 kg. Coulomb per kg, right? So this is the way how we find out the E by M ratios. Now students, we have to find out which has the identical value of E by M. Let's take the first one, that is the A option is proton and neutron. Now proton has got one charge and its E by M ratio comes out to be 9.58 into 10 to the power 7 kg. Right? Coulombs per kg. It is coulombs per kg. I hope you can find it out. That is 1.6 into 10 to the power minus 19 is the charge. So it would be 1.6 into 10 to the power minus 19 coulombs, and that is divided by the mass of proton, and that is what? It is 1.6 into 10 to the power minus 27 kg. Right? Now, neutron, does it have any charge, students? No. So E by M of neutron is equal to 0. So they are not identical. If I take the second one, the specific charge on deuterium, proton we already know. So let's talk of the specific charge or E by M on deuterium. Now we know that your deuterium is an isotope of hydrogen. What all it has got? It has got one electron and one proton plus one neutron. Hydrogen, doesn't have neutron. Now in order to find out the specific charge, what you need to do is the total charge, that is one electron, 1 into minus 1.6 into 10 to the power minus 19 coulombs, plus the charge on the proton, that is 1 into 10 to the power minus 19. Sorry students, I am not able to write here. I'll shift it a bit. So in deuterium, it is 1 into 1.6 into 10 to the power minus 19 coulombs. That is what? Minus 1.9, and this is for, let's take it, this is for proton, and for an electron it would be 1 into 1.6 into 10 to the power minus 19 coulombs, right? And this would be what, students? As it is for electrons, so it would be having a minus charge, right? And that divided by your total mass. Now what would be the total mass, students? The mass would be, it would be mass of electron plus mass of proton plus mass of neutron. So will the proton and this will have identical values? Here any case, this is a positive value, this is a negative value. That is, deuterium is neutral. So they are not having identical values, right? So your first option as well as the second option is violated. Now we have got, students, the third option. Again I told you that deuterium is neutral and alpha particle has got 2 protons. Can you tell me what is the E by M or specific charge of an alpha particle? What is alpha particle? Alpha particle is helium nucleus. Okay, so alpha particle, and this is helium nucleus, He2 plus. This has got how many protons, students? This has got 2 protons. And how many, what is the total mass of this? What is the total charge? Charge will be 2 into the charge on protons. Getting my point? So it will be 2 into the charge on protons, that is 1.6 into 10 to the power minus 19, and that has to be divided by how much? 2 into mass of proton plus 2 into mass of neutron, right? So we take mass of proton and neutron as identical. Can we say that it is 1 by 2 of the specific charge of proton? Can we say like that? Right. So the alpha particle has got a different specific charge. We calculated. So that is also not the right option. Now we have got a one good option, that is the electron and a positron. Electron, the difference between the electron and positron, what is it? Electron has a negative charge, positron has a positive charge, but their masses are the same. Okay, so their E by M ratio will be identical. Got my point? Say, I have to calculate, I'll discuss one more question related to E by M ratio. That is, what is the E by M ratio of N3 minus IM, right? Or we can say the specific charge. The question can be that what is the specific charge of N3 minus IM. What is the specific charge here? How can we find out? Now this E by M is equal to how many electrons are there in nitrogen? We need to calculate it first. Now nitrogen, the nitrogen atom has got 7 electrons. N3 minus will have how many electrons? It will have 10 electrons. Whereas how many protons? There are 7 protons here and there are 7 protons here. If I talk of neutrons, there are 7 neutrons and 7 neutrons, right? Now let's calculate the E by M ratio or the specific charge of N3 minus. So your E by M will be equal to what? That would be 10 multiplied by minus of 1.6 into 10 to the power minus 19 coulombs. That is what? That is the charge on electron. Plus, how many protons are there? There are 7 protons. So 7 into 1.6 into 10 to the power minus 19 coulombs. Got my point? Now, that is divided by the total mass. Okay, so what is the mass of it? That is 10 into 9.1 into 10 to the power minus 31 kg. Plus, how many protons are there? 7 into 1.6 into 10 to the power minus 27 kg. Right? Plus again 7 into 10 to the 7 into 1.6 into 10 to the power minus 27 kg. So students, this will be the specific charge on nitrogen ion. Just calculate this and you'll get the answer. Okay, so this is how we calculate. Likewise, you can calculate the specific charge on an alpha particle, which is what? Which is half of the specific charge of a proton. Or shall I tell you how it's half? We did that. The specific charge on a proton, I think this is closed, so I'll close it. This is specific on proton is equal to how much? It is 9.58 into 10 to the power, how many kgs? 7 kgs, coulombs per kg, right? So it is 9.58 into 10 to the power 7 coulombs per kg. Now in an alpha particle, that is your helium nuclei, you have got this thing. How many protons? There are no protons. So your E by M will be, sorry, there are no electrons. I'm sorry for that. There are no electrons. So the charge will be of the 2 protons. That is 2 proton charge upon mass of 2 protons plus mass of 2 neutrons. Right? Or we can say it would be 1 by 4 into charge of proton 1 by 2. I think let's calculate this by doing it. So that would be 2 into 1.6 into 10 to the power minus 19 coulombs upon, I think it would be a shortcut, I'll be telling you it later. 2 into 1.6 into 10 to the power minus 27 plus 2 into 1.6 into 10 to the power minus 27. That is your E by M of alpha particle, right? And what is the expression for E by M of a proton? Is equal to 1 into 1.6 into 10 to the power minus 19 coulombs, and that is divided by how many neutrons are there, or how many protons are there? 1 proton, right? So what is the mass of it? It is 1 into 1.6 into 10 to the power minus 27 kg, right? So what am I getting here? Let's calculate this. It is 2 into 1.6 3.2 into 10 to the power minus 19 upon that is, can we take it as 3.2 plus 3.2 into 10 to the power minus 27? So what will come out? 3.2 divided by 6.4, this will be 10 to the power minus 19 by 10 to the power minus 27, right? So your 3.2 divided by 6.4 would be equal to 0.5. That is equal to 0.5 into just a sec, 0.5 into 10 to the power 8 kg, right? Coulombs per kg. That is, it is coulombs per kg. Or, so what was your proton's charge? Proton's charge is equal to, that is 9.58 into 10 to the power 7 coulombs per kg, and your alpha particle, the specific charge is 5 point or something, it would be yeah 0 into 10 to the power 7 coulombs per kg. It is approximately half. If you calculate it, you can round it and make it 10, right? So the specific charge in alpha particle is approximately half of the specific charge on proton. Getting my point? This is a very important question.